So this is the third question related to maximum power transfer theorem, which we are going to discuss. So this is a circuit here, and we have been asked to find the value of RL for maximum power transfer and the maximum power transfer to this load resistor. Okay, so here, as usual, first we have to determine the Thevenin equivalent circuit across this load resistance. So we have to open circuit that. So let us redraw the circuit. 0.8 ampere, (1 ampere), and 0.9 ampere. Then we have 100 ohm, and we have to open circuit this to find first VTH. Okay, so here if you notice here, 0.8 ampere, 1 ampere and 0.9 ampere, they are all in one direction. Okay, they are all in one direction. Now if we combine them together, it will be 0.8 plus 1 1.8 plus 0.9 2.7 ampere. So we can combine them all together, add all the current values, and it will be 2.7 ampere. Again, if you notice here, this 2.7 ampere current source is connected in parallel with this 100 ohm resistor. So we can apply source transformation to convert it into a voltage source in series with the same 100 ohm resistor. So what will happen because of that? Let's see. 2.7 into 100, that is 270 volt, and in series with 100 ohm resistor across this two terminal. So if you notice, this is the exact form of the Thevenin equivalent circuit: voltage source in series with a resistor. So here VTH is equal to 270 volt and RTH is equal to 100 ohm. Okay, RTH is equal to 100 ohm. Now for maximum power transfer, as per the statement of maximum power transfer theorem, the load resistance RL should be equal to the Thevenin resistance. So here Thevenin resistance is equal to 100 ohm, so the value of RL should be equal to 100 ohm, and the maximum power that is transferred to the load resistance as a result of that is equal to, it is given by VTH square by 4 RTH. So if we calculate that, it will be VTH square is 270 square by 4 RTH. RTH is 100, 4 into 100. So let us calculate that. So it is 270 square by 400. So it will be equal to around 182.25 watts. Okay, 182.25 watts. Okay, so we have got all the three important parameters: VTH, RTH and PRL max. This. So the question was a very short one, as you can see, but the only thing to consider here was to understand, to figure out that all these three current sources are in the one direction, so we can combine them together, find the resultant current, Then the trick is to apply source transformation theorem. Then we'll get the circuit in the exact manner as we want, in the format of Thevenin equivalent circuit. So we directly got the value of VTH and RTH because of the application of source transformation theorem. Then everything was easy. We just carried on as per the maximum power transfer theorem statement. For that, the maximum power condition is RL is equal to RTH. Then we calculated PRL max. Okay, so this is the third question related to maximum power transfer theorem.